let's say that you have a solution that where the solvent is water and the solute is what we would consider drinking alcohol or ethanol. So this is our solution right over here. And let's say that it is 10% ethanol, which is drinking alcohol, and let's say the rest of it is water. And what we want to do is figure out a way that we can get something that has 15% or 20 or 30% ethanol. How would we do it? Well, the answer lies in the fact that ethanol and water have different boiling points. For example, the boiling point of ethanol is approximately 78 degrees Celsius, while the boiling point of water is 100 degrees Celsius. And so a mixture of ethanol and water is going to have a boiling point someplace in between. And so you could imagine we can keep heating up this solution. We're going to go beyond the boiling point of ethanol, but before we get to the boiling point of water, this solution is going to boil. And when it's boiling, because ethanol has a lower boiling point, the vapor mixture is going to contain more than 10% ethanol. And if you could condense that vapor, you would then have a solution with higher than 10% ethanol. And that is exactly what distillation is all about. So you might distill with a contraption that looks like this. At first it looks complicated, but then when you really understand what's going on, it's actually pretty straightforward. It's exactly what I just described. So what we would do is we would put the original solution right over here, and then you would heat it up. Oftentimes you're going to heat it up in an oil bath. That's what you see in this yellow right over here, because the oil won't evaporate readily and it can distribute the heat around in a nice even way. And then if you were to heat this up so that the solution boils, remember that's going to be a boiling point someplace in between 78 degrees Celsius and 100 degrees Celsius, you're going to for sure have some water molecules vaporizing. But at that temperature, which is beyond ethanol's boiling point, you're for sure going to have a higher proportion of ethanol molecules vaporizing. And then they're going to be in vapor form, and so they could enter this chamber right here. And what this chamber is essentially what's called a condenser. So oftentimes you're going to have separate from the vapor, but you're going to make water, cold water, go around this tube right over here, oftentimes a glass tube. Sometimes you might chill it with cold air instead. But you have water coming in, cold water, and it's going around the tube. It's not mixing with the actual air inside the tube, and then the water comes out of the tube. But what it does is it lowers the temperature in that tube. And so you can imagine the vapor that comes in that contains both ethanol and water, but the proportion of the vapor that is ethanol is going to be higher than the proportion in our original solution. It's going to condense back into liquid form. And then that stuff is just going to pour back down into what you could call this collection chamber right here. And the collection chamber is surrounded by a very cold, oftentimes ice bath, so that you minimize vaporization. Depending on how well you do this, maybe this sample right over here might be 20% ethanol or 30% ethanol. There will be still some water that comes up here and condenses and then comes back down. Now, if you wanted an even pure sample of ethanol, you could keep doing this. You could take what you collect here and then heat that up to its boiling point, which will now be a little bit lower than the first solution because it has a higher proportion of ethanol. And then you would have the same process go over and over again. And so every time you do that, you would get a pure and pure sample of ethanol. If you don't want to do that, because it's tiring and it takes a lot of work, and actually you end up with a lot of lost material through all of this mechanism over here, there's something you can do called fractional distillation. And fractional distillation is getting multiple evaporation and condensation cycles all at once so that you get a more pure sample. And the way that you get those multiple evaporation and condensation cycles is to give the vapor in this tube right over here something to condense on and then vaporize again. And you can imagine the stuff that condenses is going to have a higher proportion of the substance that has a higher boiling point. And that condensate, some of it will re-vaporize and some of it will drip back down. And the part that re-vaporizes is likely to have a higher proportion of the distillate, of the thing that has the lower boiling point. And you can have multiple cycles of this condensation and revaporization inside this column. And so at the end, you're more likely to have a more pure sample of your distillate.